Hi guys, welcome back. Today we are starting our discussion related to Kubernetes. So let's try to understand what is Kubernetes, why we need to go for Kubernetes, and what is Kubernetes architecture. The first thing, Kubernetes is an open source orchestration platform. We learned Docker in the previous classes. Docker is a containerization platform which is used to simplify application deployment process. Now here, by using Docker, we can package our application and we can execute that application inside a container. But here, to manage the containers, I want to create the containers, I want to scale the containers, I want to scale up, I want to scale down my containers. For that, we are going for Docker Swarm. Docker Swarm is an orchestration platform, right? As an alternate, there are some challenges to work with the Docker Swarm. Because if I want to scale my containers in the Docker Swarm, it is a manual process. So here I have deployed my application in the 4 containers, but I'm getting 1 lakh requests for my application. Those 4 containers will not become 10 containers automatically. So if you want to increase the count of the containers in the Docker Swarm, that is a manual process. So to avoid that problem, we are going for Kubernetes. Kubernetes is also called as orchestration platform. Kubernetes is an open source software. It is used for orchestration purpose. So Kubernetes is also called as K8s. Why it is called K8s? In the Kubernetes, first character is K, last character is S. Between K and S, there are 8 characters available. That's why they are calling it as K8s. The main use of this Kubernetes to manage our containers. Now we are using Docker containers. To manage those Docker containers, we are going for Kubernetes software. Got it? Now this Kubernetes software developed in Google company by using Go language. Kubernetes software developed by Google using Go language. It is free and open source software, and it is used to manage our Docker containers. This Kubernetes first version released in the year of 2015. Right. So what is Kubernetes? So Kubernetes we are calling as orchestration platform. Kubernetes called as orchestration platform. Kubernetes is used to manage containers of our application. Our application will have multiple containers. Front-end containers, back-end containers, database containers, API containers, like that. Multiple containers will be available in our application. To manage those containers, we are going for Kubernetes. So this Kubernetes developed by Google using Go language. Later point of time, Google company donated Kubernetes to Cloud Foundries. CNCF organization was there. They are used to deal with the cloud related technologies. Google donated Kubernetes to this company. Right. The first version of the Kubernetes released in the 2015. And this Kubernetes is free and open source. Right. Now here, as I told, Docker is a containerization platform, whereas Kubernetes is orchestration platform. Docker is used to manage application execution. Kubernetes is used to manage Docker containers. So that's why it is called as orchestration platform. In the Docker Swarm also I explained what is orchestration. So orchestration means management. Now, so here, what are the differences between Docker Swarm and Kubernetes? So Docker Swarm is also orchestration platform. Kubernetes is also orchestration platform. But what are the differences? Docker Swarm does not support auto scaling. Scaling is manual process in the Docker Swarm. So here, my application is running in 3 containers. Assume that I am running my application in the 3 containers, container 1, container 2, and container 3. In these 3 containers, my application is running. So here today, we are getting 1 lakh request for our application. To handle these 1 lakh requests, 3 containers are sufficient. Today, we are getting 1 lakh requests. To handle these 1 lakh requests, 3 containers are sufficient. Now, tomorrow, I'm having big billion day in my project. So tomorrow, I will get 10 lakh requests per minute. So today we are getting 1 lakh requests per minute. I can say 1 lakh RPM. What is the meaning of 1 lakh RPM? Per minute, 1 lakh requests are coming for our application. To handle those 1 lakh requests, we are having 3 containers. So tomorrow in our project, there is big billion day. 50% offer is available. We will get 10 lakh requests per minute. So for 1 lakh requests, 3 containers are sufficient. But for the 10 lakh requests, 3 containers are not sufficient. I need to make this count as 10 containers or 20 containers. So that is a manual process. Scaling nothing but increasing our application capacity based on the load we are getting. So how many requests are coming? Based on that, I need to increase my containers and I need to decrease my containers. So that is called scaling. So 3 containers are not sufficient. I need to go for 9 containers to run my application. I need to go for 9 containers to run my application. My application should run in the 9 containers to handle 10 lakh requests. So earlier, we are getting 1 lakh requests per minute. To handle 1 lakh requests per minute, we are going for 3 containers. But today, 10 lakh requests coming per minute. To handle 10 lakh requests per minute, 3 containers are not sufficient. I need to go for 9 containers. So who will create these 9 containers? Manually, we need to scale up. That is, manual scaling is required in the Docker Swarm. But if you go for Kubernetes, Kubernetes supports auto scaling. So what is the meaning of auto scaling? If the more number of requests are coming, it will create more containers. If less number of requests are coming, it will delete the containers. So that is called auto scaling. So Docker Swarm is orchestration platform. Kubernetes is also orchestration platform. But what are the differences here? In the Docker Swarm, we don't have auto scaling. In the Kubernetes, we are having auto scaling. What is the meaning of auto scaling? Auto scaling nothing but increasing or decreasing number of containers based on the incoming requests. If 1 lakh requests are coming, there should be 3 containers. If 10 lakh requests are coming, we should have 9 containers at least, right? So increasing the number of containers and decreasing the number of containers based on the load we are getting, that is called auto scaling. That facility is not available in the Docker Swarm. If the load is increasing, we need to increase the containers. If load is decreasing, we need to decrease the containers. That is a manual process in the Docker Swarm. To avoid the challenges in the Docker Swarm, we are going for Kubernetes. What this Kubernetes can do? Kubernetes can support auto scaling. So if the number of requests are increasing, Kubernetes will increase your containers. If number of requests are decreasing, Kubernetes will decrease your containers. So that is called orchestration. Orchestration nothing but managing the containers. Docker is a containerization platform. Docker Swarm is orchestration platform. As a replacement for the Docker Swarm, we are going for Kubernetes. Guys, remember, Kubernetes is not replacement for the Docker. Kubernetes will use Docker container only. Kubernetes will manage Docker containers only. Kubernetes is a replacement for the Docker Swarm, not for the Docker. That point is very important. So Kubernetes is replacement for the Docker Swarm, not for the Docker. So what is Kubernetes? Kubernetes is called as orchestration platform. What is the meaning of orchestration? Management is called as orchestration. Docker is a containerization platform. Kubernetes is an orchestration platform. Kubernetes is used to manage containers of our application. This Kubernetes is developed by Google using a Go language. Google donated Kubernetes to CNCF. CNCF, nothing but Cloud Foundry. The first version of the Kubernetes released in the 2015. This Kubernetes is free and open source. Now, so Kubernetes will use Docker containers internally. Kubernetes will use Docker internally. Kubernetes will use Docker internally. Got it? It is used to manage Docker containers only. Using Kubernetes, we will manage our Docker containers. Okay. So I have containers. I want to scale my containers, scale up my containers. I want to scale down my containers. For that, we are going for Kubernetes. Now, what is a Docker Swarm? Docker Swarm is orchestration platform. Kubernetes is replacement for the Docker Swarm. So Docker Swarm does not have auto scaling. Kubernetes supports auto scaling. Guys, can you tell me what is auto scaling? Can you guys tell me what is auto scaling? Come on, guys. What is auto scaling? Increasing and decreasing the containers based on the load. Increasing and decreasing the containers based on the load is called as auto scaling. Auto scaling. Increasing and decreasing containers count based on incoming requests for our application. If 1 lakh requests are coming, 3 containers should be available. If 10 lakh requests are coming, 9 containers should be available, like this. So here, instead of I am adding the containers and deleting the containers, here my orchestration platform should have that auto scaling. Auto scaling facility is not available in the Docker Swarm. That's why for the production deployment, Docker Swarm is not recommended. When you want to deploy your application in the production environment, then Docker Swarm is not recommended. For production deployments, we need to go for Kubernetes. For production deployments, Kubernetes is highly recommended. Kubernetes is a replacement for the Docker Swarm. Kubernetes is replacement for the Docker Swarm. Increasing and decreasing the containers count based on the incoming request for our application is called as auto scaling. Now, Kubernetes will run based on the cluster. So in the Docker Swarm also I explained what is a cluster. So cluster is nothing but group of servers. So Kubernetes will work in the cluster mode. So Kubernetes is going to work in the cluster mode. What is the meaning of cluster mode? In the cluster mode, group of servers will be available. One server we will call as a master node. The remaining servers we are going to call as worker nodes. It is like a manager and a team. For every team members will be available and the manager also will be available. What is the duty of the manager? Manager will do the work, or manager will assign the work and will monitor the work. Guys, in the team, manager will do the development and testing, or manager will assign the work to the team members and will monitor the work. Come on, guys. Manager will do the work, or manager will assign the work and will monitor the work. Manager will assign the work and will monitor the work. Same thing here. Docker Swarm also will use a cluster mechanism. Any orchestration platform. If you go for any orchestration platform, the orchestration platforms are going to run in the cluster manner, cluster architecture. So orchestration, if you go for Docker Swarm, there also we have done the cluster setup, right? So here also we are doing the cluster setup. So here master node will be available and worker node will be available. Master node is nothing but a manager. Master node is nothing but a manager. Worker nodes are nothing but the assistants, or I can say team members. Now here the worker nodes will be created. The worker nodes will be assigned to the master node. Worker nodes will be available. Worker nodes will be assigned to the master node. So this is called cluster. Cluster. Now I want to deploy my application. So the deployment task I will give to the master node. Master node will assign the task to the worker node and the master node will manage the worker node. So this is called cluster. So what is a cluster? Cluster is nothing but group of servers. Instead of taking only one machine to run our application, for example, I have taken one Docker machine. In that Docker machine, I'm running my Docker container. So my application is running in one container. That container is running in one machine. Suppose, for example, If this machine got crashed due to some hardware issue, my machine got crashed. If my machine is crashed, my container will be down, my application will not be accessible. So we should never run our application in the single machine. If we run our application in the single machine, then there is a chance of single point of failure. So I'm taking one machine. In that machine, I installed Docker engine, and I am executing my application in that machine. Okay, guys. So I'm taking one machine. In that machine, I'm installing the Docker. Using that Docker, I'm running my application in the Docker container. Okay, fine. My application is running as expected. Everything is good. All of a sudden, my machine got damaged. My system got damaged, in which my application is running. Only one machine and only one container. That application got crashed. That system got crashed. Then that point is called single point of failure. So here, is it recommended to run our application? Is it recommended to run our application in one machine, or it is not recommended to run our application in one machine? Guys, is it recommended to run our application in one machine, or it is not recommended to run our application in one machine? It is not recommended to run our application in one machine. So that's why in the real time, our applications will be deployed in the cluster. What is a cluster? Cluster nothing but group of servers will be available. So in those group of servers, we are going to consider some machines as a master node machines, and some machines we are going to consider as a worker node machines. So you need to consider the master node as a manager. So it will play the role as a manager. And these worker nodes are going to play the role as the team members, assistants for the manager. So whenever a request comes, whenever a requirement comes to the manager will assign the task to the team members and will monitor the work of the team members. Same thing here, when you go for the cluster, group of servers will be available. Why we have group of servers here? I don't want to run my application on the single container. I don't want to run my application on the single machine. If I run in the single container, if I run in the single machine, there is a chance of failing. There is a chance of failing. So application may fail. Application may fail, right? So here, there will be a downtime if our container is damaged, or if our system is damaged, there will be a downtime for the application. That is called single point of failure. Have you ever seen the Flipkart application is down, Amazon application is down, Gmail application is down? Have you ever observed that? Have you ever observed LinkedIn application is down? Have you ever observed Naukri application is down? Have you ever observed YouTube application is down? Very rare scenario, right? Very, very, very rare. Why? Those applications are available 24/7. Why those applications are available 24/7? How those applications are managing millions of requests? How many people will use YouTube daily? How many people will use Gmail daily? How many people will use Google daily? How many people will use Instagram daily? Do you think that Gmail, Facebook, Flipkart, WhatsApp, LinkedIn, YouTube, Google will run in one container, in one machine? Do you think that they will run their application in one machine? If they run their application in one machine, definitely these many people cannot access those applications at a time. If they are running their project in one machine, these many people cannot access that application. That machine cannot handle this much load. Definitely, in the real time, our applications will be executed in the cluster mode. In the real time, every application will execute in the cluster mode. What is the meaning of cluster? Master node will be available and worker nodes will be available. In master node is responsible to handle the work and assign the work to the worker nodes. So whatever the application is available, suppose for example, Facebook application will run in the worker node 1 will run in the worker node 2, will run in the worker node 3. So same application will be executed in the 3 containers. Those 3 containers will be created in the 3 different machines, not in one machine. So if I create one container in one machine, if that machine is damaged, then application will be down. If I create 3 containers in one machine, if the machine is damaged, application will be down. So that's why in the real time, our application will be deployed into multiple containers in multiple machines. That is called cluster. What is a cluster? Cluster is nothing but group of servers. In the cluster, master node will be available and worker nodes will be available. What is the duty of the master node? Master node will get the request to deploy our application. As a DevOps engineer, I will tell to my master node, hey master node, deploy my application in the 10 containers. Then master node will take my requirement. Master node will assign the task to the worker nodes which are connected to the master node. 10 containers will be created in the worker nodes. For example, so 3 containers will be created here. 3 containers will be created here. Another 3 containers will be created here. Here 4 containers will be created. Like this, my application will run in the 10 containers in the 3 machines. So tomorrow, if any one container is failed, no problem. Still, there are 9 containers available. Here, this container is failed, no problem. Still, we are having 8 containers. Suppose this complete machine is damaged, no problem. Already 2 machines are available, 5 containers are available. So like this, we need to have the safe mechanism to run our application. If you go for one machine, one container, if that container is damaged, our application will run into single point of failure. That means application is down, people cannot access your application, business is down. If you run one container, always there is a problem. If you run in one machine, always there is a problem. That's why in the companies, real time projects will be deployed into multiple containers in the multiple machines. That concept is called cluster. That concept is called cluster. Group of servers will be available. Group of servers will be available. In those group of servers, some servers we are going to take as master node. Some servers we are going to take as a worker node. For high availability, people will take multiple master nodes also. Not the single master node. People can take multiple master nodes also. There is a chance of master node fail. So that's why instead of taking one master node, we can take multiple master nodes so that we will have high availability. High availability, nothing but at any point of time, my application should be available. There should not be any downtime for my application. So that's why we are going to run the applications in the cluster. Now, master node will manage the worker nodes. Master node will schedule the task to the worker nodes. Our containers will be created in the worker nodes. So this is called cluster. If you have practiced Docker Swarm, it is easy for you to understand what is cluster, how to set up the cluster. Okay, guys, Docker Swarm is also a orchestration platform. But what is the problem in the Docker Swarm? Docker Swarm does not have auto scaling. So if the more number of requests are coming, I need to create more containers. If less number of requests are coming, I need to decrease the containers. Increasing the container count, decreasing the container count is a manual process in the Docker Swarm. It is inbuilt functionality in the Kubernetes. Kubernetes will run in the cluster mechanism. What is the meaning of a cluster? Cluster, nothing but group of servers will be available. So here we will call them as master nodes and worker nodes. So now I am a DevOps engineer in my project. I want to deploy my application containers. So we are using Docker to run our applications. Docker is a containerization platform. By using Docker, we can create the image. We can package our application dependencies plus application code as a Docker image. Using that Docker image, we can create the container. So earlier we created the containers manually. Now I don't want to create the container manually. I want to create the container by using Kubernetes. Kubernetes is responsible for orchestration purpose. So Kubernetes is used for orchestration. What is the meaning of orchestration? Managing the container. How Kubernetes is going to manage our containers? How Kubernetes will execute? Kubernetes will execute in the cluster, right? What is a cluster? Cluster is nothing but group of servers. Here, master node will be available and worker nodes will be available. So now, as a DevOps engineer, I will give the task to master node. Hey, Kubernetes master node. So this is my Docker image. You create 10 containers for this Docker image. Then Kubernetes master node will take my request, will schedule the tasks to the worker nodes. 10 containers will be created in the 3 worker nodes. Like this, you can take multiple worker nodes and multiple master nodes. So what is the advantage if I have multiple worker nodes? If one machine, one node, nothing but one machine. If one machine is failed, no problem. Other machines will be available to run our application. So if one container is failed, no problem. Other containers will be available to run our application. So this is a cluster that we are going to use. This kind of cluster we are going to use to run our applications in the real time. So now, running the application in one container in one machine is recommended. Running the application in the multiple containers in the multiple machines is recommended. Guys, running the application in one container in one machine is recommended. Running the application in multiple containers and in the multiple machines is recommended. Which is recommended? Multiple containers and multiple machines. Why we need to go for multiple containers and multiple machines? Why we need to go for multiple containers and multiple machines? What is the benefit of going for multiple containers and multiple machines? What is the benefit of going for multiple containers and multiple machines? High availability. High availability. Right. If there is any failure, still our application will be accessible. If one container got damaged, if one node got damaged, no problem. Other nodes will be available to access our application. That is called cluster. Kubernetes is going to execute in the cluster structure. By using this cluster, we can avoid single point of failure. We can avoid single point of failure. Using a cluster, we can achieve high availability. Using cluster, we can achieve high availability. Using cluster, we are going to achieve high availability. Okay. Now, let's understand what is our Kubernetes architecture. Guys, understanding Kubernetes architecture is very, very, very important. Okay. So if you see the Kubernetes architecture diagram, so first in this Kubernetes architecture, you can see that there is a control plane available. There is a control plane available. Control plane is called as master node in the Kubernetes. So when you go for cluster, master node will be available and worker nodes will be available. So we don't call it as a master node, we call it as a control plane in the Kubernetes. In this Kubernetes architecture, master node is called as control plane. Inside the control plane, we are having 4 components. Can you please read the 4 components in the control plane? I'm telling you once again, Kubernetes is not that much easy. Kubernetes is not that much easy. Don't miss the live classes. Sir, we are getting the backup videos. We'll see the backup videos. If you see the backup video, you will not understand anything. Kubernetes is the most difficult part in the whole DevOps course. Even the people who are working on the DevOps with 5 to 6 years of experience also struggling to understand the Kubernetes concepts. Lot of depth is there in the Kubernetes. It is not easy to understand the Kubernetes. So please don't miss the classes. So Kubernetes is damn important to attend your interview also. Without asking the questions on the Dockers and Kubernetes and Jenkins, your DevOps interview will not be completed. If you are not strong in the Dockers and Kubernetes, so definitely you cannot crack that interview. And yesterday I have seen people got 22 marks, 25 marks, 30 marks out of 50. After spending 10 days for the Docker classes, you people got the 22 marks. So it's too bad. I got disappointed. I expected everybody 45 plus marks in that, at least. But there are so many people who got the 20, 22, 18, 26, 32, 31. Below 40, there are so many people available. That means you are not practicing. There is no use of attending this course if you are not practicing this. Right. Now, let us try to understand Kubernetes architecture. Kubernetes is an orchestration platform. It is used to manage our Docker containers. So in the Kubernetes architecture, we can see a cluster, right? So in the Kubernetes, the most important component is control plane. In the Kubernetes, the most important concept is control plane. The first one is API server. Second one is scheduler. Third one is controller manager. And fourth one is etcd. So what is this API server? When I want to deploy my application on the Kubernetes cluster, I will send a request to control plane. Now I want to run my application. Here I'm a DevOps engineer. I want to run my application. To run my application, I will create a Docker image. Docker image I will give to the Kubernetes control plane. I will send a request to the Kubernetes master node. So now master node is called as a control plane in the Kubernetes. When I send a request to the control plane to deploy my application as a Docker containers, in the control plane, API server will be available. API server will receive the request and it will store the request in the etcd. So when you want to deploy your application by using Kubernetes platform, you will send a request to the control plane in the Kubernetes. Control plane is called as a master node. That Kubernetes API server is responsible for handling incoming requests of control plane deployments. So whatever the deployments that I want to do, those deployments, DevOps engineer will send it to the Kubernetes cluster. In the Kubernetes cluster, control plane will be available. In that control plane, API server will be available. What is API server? API server is responsible to handle incoming requests of the control plane to deploy our applications. To deploy our applications, we will be sending the request to the API server. API server will receive the request and the API server will store the request details in the etcd. What is etcd? etcd is an internal database in the Kubernetes cluster. API server will store the request details in the etcd. Guys, this is not end user request to access our application. This is a deployment request. DevOps engineer will send the deployment request to Kubernetes cluster. So hey Kubernetes, create Docker containers for my application. 10 containers you need to create. So for that, DevOps engineer will send a request to the Kubernetes control plane. In the Kubernetes control plane, API server will be available. API server will receive incoming request for the control plane to deploy our applications. Once API server received our request, API server will store the request in the etcd. What is etcd? etcd is an internal database in the Kubernetes cluster. API server will store requests or tasks information in the etcd. So whatever the requests came to deploy our application, those requests will be stored into etcd. After storing the request in the etcd, then scheduler will come. So what is the scheduler? Schedule is responsible to schedule pending tasks available in the etcd. So DevOps engineers sent one request to deploy MySQL database in the Kubernetes cluster. So I want to deploy MySQL database. I want to run MySQL database as a Docker container in the Kubernetes platform. So Docker is a containerization. Kubernetes is orchestration. Orchestration means managing the containers. I want to run MySQL database as a Docker container in multiple nodes, in multiple machines. I want to run my database in multiple machines. As a DevOps engineer, I will send my request to Kubernetes control plane. So I want to deploy MySQL database. API server will take that request to deploy the MySQL database in the cluster. It will store that request in the etcd. So once the request is stored in the etcd, scheduler will start, scheduler will come and scheduler will go to etcd, scheduler will check what requests are pending in the etcd. Scheduler is responsible to schedule pending tasks available in etcd. It will decide in which worker node our task should execute. Scheduler will decide that by communicating with the kubelet. Are you guys able to follow me? So there is a API server and etcd and there is a scheduler. What is the responsibility of the scheduler? Scheduler is responsible to schedule pending tasks available in the etcd and it will decide in which worker node our task should execute. Scheduler will decide that by communicating with the kubelet. So there are 3 worker nodes available. So I asked to deploy MySQL container. So where that MySQL container should be created? It should be created in the first worker node or second worker node or third worker node. Where your database container should be created, that information will be identified by scheduler. How scheduler will identify? Scheduler is going to talk to worker node agent. So like this worker nodes will be available. These worker nodes will be connected to the control plane. So as I told you, the Kubernetes is running in the cluster mode. So control plane available and worker nodes are available. The worker nodes are connected to our control plane. Now I have sent a request to the Kubernetes control plane to deploy my MySQL database. My request received by API server. API server is one core component in the control plane of Kubernetes. Control plane nothing but master node. This master node is connected to the worker nodes. Worker node 1, worker node 2, like this multiple worker nodes will be available. Worker node 1 and worker node 2. In every worker node, there will be a component called kubelet. In every worker node, there is a component called kubelet. Kubelet is called as worker node PA, worker node assistant. So if you have seen our heroes, heroines, politicians, they will have a personal assistant. TA will be available. So the TA will decide so the schedule for that politician or for that celebrity. So today morning at 8 o'clock, which meeting is available, 9 o'clock, which meeting available, what is your daily schedule, that will be decided by personal assistant. Your personal assistant will know what is your day schedule. Got my point? Similarly, in the worker nodes, there will be one PA that is called kubelet. Kubelet is called as worker node agent. Kubelet is called as worker node agent. Now here we have kubelet. Kubelet is called as worker node agent. This kubelet will maintain all the information related to the worker node. API server, etcd, scheduler, kubelet. Right? So when we send a request to the control plane, API server will receive the request. API server will store the request in the etcd. etcd is the internal database in the Kubernetes. Then scheduler will come. Scheduler will go to etcd. Scheduler will identify which requests are pending in the etcd. Then scheduler has to schedule the task. In which worker node it has to schedule, in which worker node that container should be created. For that, our scheduler is going to interact with the kubelets. What is a kubelet? Kubelet is called node agent. For every worker node, one kubelet will be available. Scheduler will talk to first worker node kubelet. Hey kubelet, do you have any containers? How much space is free for you? So can I create a container in the worker node? Like that, that scheduler will talk to kubelet, will identify the node information. Which node is free, then scheduler is going to schedule our container creation on that particular node. Scheduler will tell to controller manager, hey controller manager, go and create this pod in the first worker node. Then controller manager will give the request to the worker node to create the container. So like this, whenever you send any requirement to deploy your Docker container to the Kubernetes, control plane is going to handle that request. Control plane will assign the request to the worker node. Your container will be created in the worker node. API server, scheduler, controller manager, etcd. API server is responsible to handle incoming request to deploy the applications. That incoming request will be stored into etcd database. Etcd is a in-memory database in the Kubernetes. Then scheduler will come. Scheduler will go to etcd, will check what are the pending requests are available. Then scheduler will talk to kubelets. Kubelet is nothing but a node agent. So by using that kubelet, it will get the node information. Once it is done, controller manager will go and schedule that task to execute on that particular worker node, which is decided by the scheduler. Then that container will be created on that particular worker node. Right. Now here, how to send request to control plane. As a DevOps engineer, how can I have my Docker image. I have my Docker image in the Docker Hub. How can I send a request to control plane to deploy my application in the Kubernetes cluster? That's where we are going to use kubectl, or people will call it as a kubectl. Some people will call it as a kubectl. Some people will call it as a kubectl. Kubectl is one CLI software which is used to communicate with the Kubernetes control plane to send the deployment request. If you don't want to go with the kubectl, you can go with the user interface also. Kubernetes providing a web dashboard. By using that web dashboard also, we can interact with the control plane to schedule our deployments. I want to deploy my Spring Boot application in the Kubernetes cluster. First, we need to have a Docker image. Once I have a Docker image, I need to tell to control plane to deploy my application in the Kubernetes cluster. So how many ways I can interact with the control plane? I can interact with the control plane in two ways. One is by using user interface, web dashboard, and second one is by using kubectl. Kubectl is called as a CLI software which is used to communicate with the Kubernetes control plane. Kubectl is a CLI software which is used to communicate with the Kubernetes control plane. Are you guys able to follow me? Are you guys able to follow me? What is the kubectl? What is the kubectl? What is the purpose of kubectl? Now tell me, Kubernetes is easy or Kubernetes is difficult? Kubernetes is easy or Kubernetes is difficult? Kubernetes is difficult. I'm upfront, I'm telling you, Kubernetes is difficult. See, architecture itself is a lot of confusing. And now we need to work with this architecture. And lot of demand is there for Kubernetes in the market. If you are confident on the Kubernetes, if you are strong in the Kubernetes, definitely you will crack the interview. Because most of the DevOps questions they will ask on the Kubernetes only. Subject is very interesting and very challenging also. Kubernetes subject is very interesting and very challenging also, and difficult also. Slowly we need to understand and we need to become perfect in the Kubernetes. Right. kubectl. kubectl is a CLI software which is used to communicate with the Kubernetes control plane. I want to deploy my Docker containers in the Kubernetes. So I want to communicate with the control plane. Control plane, nothing but one machine. So in order to communicate with that machine, I will use kubectl as a CLI software. I will use kubectl as a CLI software. Able to follow me? kubectl is a CLI software which is used to communicate with the control plane. If you don't want to go with the kubectl, then you can go for user interface. By using user interface also, we can communicate with the control plane. So through UI, we can communicate with the control plane. With the kubectl, we can communicate with the control plane. UI means web page will be available. Using web page, web application will be available. Using that web application, we can communicate with the control plane. kubectl means command line will be available. Like our git bash, a CLI tool will be available. Using that CLI also we can communicate with the control plane. What is API server? API server is core component in the control plane, which is responsible to receive the requests from the kubectl or from the UI for the deployments. DevOps engineers will send the deployment request to the control plane by using kubectl. Then in the control plane, API server will be available. API server will take that request, will store the request in the etcd as a pending request. What is etcd? etcd is a in-memory database in the Kubernetes. Once the request is received by API server stored in the etcd, so scheduler will be available. Scheduler will go to etcd. Scheduler will check what requests are in the pending state. Now, what are the pending requests are available? Scheduler has to schedule those requests. So where it has to schedule? It has to schedule in the worker nodes. So worker nodes will be connected to control plane. For every worker node, one node agent will be available. That node agent is called as a kubelet. Kubelet will give all the worker node information to the scheduler. Based on the worker node information, scheduler will decide the container should be created in the which worker node. It will decide that. Once it is decided, controller manager will send that task to that particular worker node. In that worker node, our container will be created. In order to create the container in the worker node, Docker engine should be available. In the worker node, Docker engine will be installed. Why Docker engine? To run the Docker container, Docker engine is required. So in the worker nodes, our containers will be created. As we are going to create the containers in the worker node, in the container machine, Docker software should be installed. Kubernetes is not the replacement for the Docker. Kubernetes is using the Docker internally. I want to run my Docker container in the worker node. So to run my container in the worker node, Docker engine should be installed. What is a control plane? Control plane is nothing but master node. Control plane nothing but master node. Okay. This control plane nothing but master node. This master node will manage the worker nodes. In the worker node, kubelet will be available and Docker will be available. Why Docker should be there in the worker node? Why Docker should be there in the worker node? Guys, why Docker is required in the worker node? Containers are executing on the master node. Containers are executing in the worker nodes. Containers are executing in the master node or containers are executing in the worker nodes. Containers will be executed in the worker nodes. So that's why the Docker is required to run the container. In the worker node, Docker will be installed. Are we installing Docker in the master node control plane? Are we installing Docker in the control plane? No, because containers are not running on the control plane. Containers are running on the worker nodes. That's why Docker will be available in the worker nodes. Got it? What is a kubelet? Kubelet is called as worker node agent. It will maintain all the information related to worker node. Good. Next one, what is queue proxy? Queue proxy will provide the network for communicating with the control plane and master node. So now here, what is queue proxy? Queue proxy will provide the network so that worker node can connect with the control plane can connect with the worker node. Queue proxy will provide the network communication. Kubelet is a node agent. Kube proxy will provide the network connection between the control plane and the worker nodes. People are asking what is etcd full form? There is no full form for the etcd. That is the name itself. etcd nothing but a data store, database in the Kubernetes. There is no full form for etcd. Okay, guys. Queue proxy. What is queue proxy? Queue proxy will provide the network communication to connect from control plane to worker node to control plane. So worker node should connect with the control plane should connect with the worker node. For that, network is required. That network will be provided by queue proxy because so worker node 1 means one machine, worker node 2 means another machine, control plane means another machine. These are 3 machines available. These 3 machines should be connected, right? They should communicate. For that, network is required. That network will be provided by queue proxy. That network will be provided by queue proxy. You got my point? Yeah. And next one, another most important thing is pod. In the Docker, everything will be represented as a container. In the Kubernetes, everything will be represented as a pod. Pod is nothing but the smallest building block that we will create in the Kubernetes to run our containers. So when we have a Docker image we will run, then Docker container will create. When we ask Kubernetes to run our application, Kubernetes will take the Docker image. Kubernetes will create a container inside the pod. Pod is nothing but the smallest building block that we can run in the Kubernetes cluster. In the Docker, everything will be represented as a container. In the Kubernetes, everything will be represented as a pod. So if you ask the Kubernetes to run your application, Kubernetes will run your application inside the pod. Your containers will be created inside the pod. Pod is the smallest building block that we can deploy in the Kubernetes cluster. Okay, now see here. Now, Kubernetes architecture. This is the whole architecture of the Kubernetes. Control plane. What is control plane? Control plane is nothing but a master node. Control plane will act as a master node. In the Kubernetes, control plane will be available. Control plane is called as master node. It's called as master node responsible to handle Kubernetes related work. Right. Then we have worker nodes responsible to execute our application as pods. Right. Control plane is called as master node. It is responsible to handle Kubernetes related work. What is worker node? Worker nodes are responsible to execute our application as pods. Now, in the control plane, API server, scheduler, controller manager, and etcd. What is API server? API server is responsible to handle incoming requests of the control plane to deploy our applications. So whatever deployment request that we want to send, we will send to the control plane. Now, when we send the request to the API server will take the request, will store the request in the etcd. etcd nothing but a database where the pending request will be stored. Scheduler will go to the etcd, will identify the pending request, will schedule that request. How scheduler will schedule? Scheduler will decide our application should be deployed on the which worker node. So scheduler will connect with the worker node by using kubelet. What is a kubelet? Kubelet is nothing but node agent. Kubelet is an assistant for the node. Based on the information given by the kubelet, our scheduler will schedule the pods in the worker nodes. Right. So who will send the task to the worker node? Control scheduler will identify which worker node we have to use. Then controller manager is going to send that task to the worker node to create the pod. As these scheduler and controller manager want to talk to the worker nodes, there should be some connection. There should be some network. That network will be provided by kube proxy. Kubelet is called as a node agent. Kube proxy will provide the network to communicate from control plane to worker node to the control plane. Then here my application should be executed as a container, Docker container. To run the Docker container, Docker should be installed in the worker node. Then how our containers will be created? So is Kubernetes creating the containers directly? No, Kubernetes will not create the containers directly. Kubernetes will create containers inside the pod. Kubernetes will create the containers inside the pod. What is a pod? Pod is a smallest building block. Pod is a smallest building block that we will create in the Kubernetes to run our containers. So our containers will run inside the pod. Containers will run inside pod. Okay. Kubernetes has to manage the containers, right? So container is nothing but a Docker concept. Kubernetes will not have any control on the Docker container. That's why Kubernetes will create the container inside the pod. Pod is a Kubernetes concept. So if I want to delete the container, that means we need to delete the pod. If I want to scale the container, we will scale the pods. Scale up the pods, scale down the pods. So everything we are going to represent as a pod in the Kubernetes. In the Docker container will be available to run our application. In the Kubernetes, pod will be created. Inside the pod, Docker container will be created. Now, based on the demand, Kubernetes can increase the count of the pod, can decrease the count of the pod. That is called auto scaling. So pods, if I want to scale my application, I want to run my application in the 10 containers, then I will go for 10 pods. If more number of requests are coming, my pods should be increased. If less number of requests are coming, my pods should be decreased. So in the Kubernetes, our containers will be managed in the pod. Pod is the smallest building block that is used to run our container. Now, how to send the request to control plane? So directly we can't send the request to control plane. We can go for either kubectl software or we can go for web dashboard. By using user interface, we can send the request to the control plane, or by using kubectl CLI also we can send the request to the control plane. Control plane will take our request, will schedule the request to the worker nodes. Worker nodes are going to create the pods. Pods will contain our application container. So this is architecture of the Kubernetes. Very, 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 very important. Why we need pod? Kubernetes architecture. In the Kubernetes, if you send a request to run your application in the Kubernetes, by default, Kubernetes will create the pod. Without pod, there is no use of Kubernetes. In the Kubernetes, everything will be represented as pod. Can we have multiple containers in one pod? In the diagram, clearly it is saying that in one pod, 3 containers are available. What is the meaning of that? In one pod, you can run multiple containers also. In one node, you can run multiple pods. In one pod, you can run multiple containers. That is already representing in the diagram. What is a kube proxy? Kube proxy will provide the network communication between the control plane and the worker nodes. Control plane should connect to the worker node. Worker node is one machine, control plane is one machine. So one machine should connect to that another machine. But that network will be provided by kube proxy. Right. So do I need to deploy same container in all the pods? Not mandatory. In pod 1, I will run one application. In the pod 2, I can run another application. It depends upon that, right? Depends upon. Yeah. Are you clear with the Kubernetes architecture? What is a Kubernetes? Kubernetes is an orchestration platform. It is used to manage our containers. It is developed by Google using Go language. It is donated to CNCF organization. Kubernetes first version released in the 2015, and Kubernetes is free as well as open source. You don't need to pay the money. Kubernetes will use Docker internally. Using Kubernetes, we will manage our Docker containers. Managing the containers is called as orchestration. What is the meaning of managing? Creating the containers, increase the containers, decrease the containers. That is called orchestration. Earlier, before Kubernetes, people used it to work with a Docker Swarm. But a Docker Swarm does not have auto scaling. Scaling is a manual process in the Docker Swarm. So to overcome that problem, we are going for Kubernetes. For production deployments, auto scaling is required. So that's why Docker Swarm is not recommended for the production. For the production deployments, we are going for Kubernetes only. We can say Kubernetes is a replacement for Docker Swarm. What is the meaning of auto scaling? Increasing and decreasing the container count based on incoming request for our application is called as auto scaling. What is a cluster? Cluster is nothing but a group of servers. Okay, guys. Master nodes will be available. Worker nodes will be available. We will send the request to the master node. Master node will send the request to the worker node. Got it? What is Kubernetes architecture? In the Kubernetes architecture, control plane will be available and worker nodes will be available. In the Kubernetes architecture, control plane will be available and worker nodes will be available. How can we communicate with the control plane? Either by using user interface or by using kubectl. In the control plane, API server, scheduler, controller manager, etcd available. In the worker node, kubelet will be available, kubeproxy will be available, Docker will be available, pods will be available. So this is the architecture. Here I have explained what is the purpose of each component. API server responsible to handle incoming requests and store in the etcd. etcd is a database to store the pending requests. Scheduler will identify the pending requests, will identify the worker node to deploy our application by communicating with the kubelet. Kubelet is a worker node agent. Control manager, after scheduling completed, control manager will manage our task execution in the worker node. Kubeproxy. Kubeproxy will provide the network for Kubernetes cluster communication. Master node to worker node to master node. That cluster communication will be managed by kubeproxy. What is a Docker engine? Docker engine is used to run our containers, right? Containers will be created in the worker nodes. So is it going to run the container directly? No. So containers will be executed inside the pod. What is a pod? Pod is the smallest building block that we can run in the Kubernetes. If you want to deploy your application in the Kubernetes, that means it will create the pod for our application container. Containers will be created inside the pod. In one pod, you can create multiple containers. In one worker node, you can create multiple pods. Pod 1 representing front-end application, pod 2 representing back-end application, pod 3 representing database. Like that also, you can create multiple pods with multiple applications. Or you can deploy same application in multiple pods. Anything is possible. Scaling will happen in the pods. If I want to scale, pods will be increased. I want to scale my application. So if more number of requests are coming, more pods will be created. If less number of requests are coming, less number of pods will be available. Got it? Sir, can we delete particular container in the pod? No, you can't directly deal with the containers in the Kubernetes. In the Kubernetes, you have to delete the pod or you have to create the pod. In the Docker, we created the containers directly. We deleted the containers. In the Kubernetes, we cannot touch the containers directly. In the Kubernetes, we need to deal with the pods only because container is a Docker concept. Here, Kubernetes will not have any control on the container. Kubernetes will have the control on the pod. If you want to increase the containers, increase the pods. If you want to decrease the containers, decrease the pods. If you want to delete the container, delete the pod. If you want to create the container, create the pod. Everything is a pod now. Can one pod communicate with the other pod? Yes, we can do that. We can do that. How to decide how many pods are required for your application? That is auto scaling. Kubernetes will decide that. You don't need to decide. Based on your CPU usage, based on your memory available in the worker node, Kubernetes control plane will decide how many pods are required to run your application. How to track particular pod is failed or not. So today is the first session. Today is the first session. Troubleshooting all that. First of all, we need to set up this architecture, right? Aapka jaan le lega. First, we need to set up the architecture. Then we will see how to create the pods, how to track the pods, how to increase the pods, how to decrease the pods, how to delete the pods. If your pod is failed, how to track that, how to check the logs of the pod. Everything will come. Have some patience. Scheduler will identify in which worker node pod should be created. Controller manager will send that task to that particular worker node based on the instruction given by the scheduler. How many containers should be there in the pod? That we will write the manifest files. We need to write the configuration file. In the configuration file, we will decide how many containers should be created in one pod. So everything will be a YML configuration here. In the YML file, we are going to specify that. What is there in the kubelet? Kubelet will maintain how much memory utilized in the worker node, how much memory is available in the worker node, how much memory utilized in the worker node, how many pods are running in the worker node, can we create a new pod in the worker node or not, do we have a space to run the new pod or not. All that information will be maintained by kubelet. Kubelet is called as a node agent. Got it? All questions clarified? Who is responsible for auto scaling? Control plane is responsible for auto scaling. Control plane will decide the auto scaling. Control plane will do that. In worker node, what is the use of Docker? In the worker node, pod will be created. Inside the pod, container should be created. Container is a Docker container, right? To run the Docker containers, Docker engine is required. So that's why Docker will be available. Without a Docker, container cannot be created. We don't create the container manually. Pod will create the container, right? So to run that container, Docker engine is required. Yeah, perfect. So still, if anybody having questions, unmute and ask.
Ashok, can we have all the front-end, back-end, and database containers in a single pod?
You can keep it, but it is not recommended.
Okay.
Because if the pod is deleted, everything will be done. Everything will be gone, right?
Okay.
So we can create multiple containers in one pod. Technically, it is possible, but not recommended. We will keep one container in one pod.
In real life, do we have a control plane, like one instance of control plane or more than one?
If you are using cloud platform like AWS cloud, then one control plane is sufficient. If you are, so tomorrow, the tomorrow topic is that only how to set up the Kubernetes cluster. When you are going for Kubernetes cluster, right? If you go for Kubernetes managed cluster, one control plane is sufficient. If you are creating your own Kubernetes cluster, then multiple control planes are recommended.
Hello.
Yeah.
Hello.
Yes, sir.
Sir, actually, I want to ask, can we say one of the property of Kubernetes is load balancing of application? Is it correct?
It is one of the concepts. It can do the load balancing.
Means we can say one of the property of Kubernetes
is load balancing. Yes, it can do that.
So here I have one question. We apply the load balancing through ribbon in Java, and we apply the load balancing through Kubernetes in AWS. So what is the
when I will explain load balancing concept in the Kubernetes, then you will get the clarity. For time being, remember that Kubernetes can do the load balancing of our application. Kubernetes can do auto scaling for our application. When that topic comes, you will get the more clarity.
Okay. Thank you.
Sir, once you can brief about the controller manager, sir.
Scheduler will why you people are not concentrating on the classes. Every concept I explained five times. Every concept I explained five times. Scheduler will identify in which worker node the task should be executed. The task execution will be taken care by controller manager. Scheduler will identify our pod should be created in the which worker node by talking to kubelet. It identified that in the first worker node our pod should be created. Then controller manager will send that pod information to that worker node. Controller manager is responsible for actual task execution. Where that task should be executed will be decided by scheduler.
Sir, is it like the control manager has a single instance so that it needs a scheduler like what to do and in which order or
It will be
something?
taken care by control plane. What to do, where to do, how to do, everything will be taken care
Okay.
by control plane. We need to provide the configuration information. Where is our Docker image? How many pods you want to create? What container should be there inside the pod? Everything will be provided as a information to the control plane.
And this
Ashok,
API server, scheduler, and these components.
Hey, ready ka bhai?
Sorry.
API server, scheduler,
No.
all these components will be available in the control plane.
Sir, in
Hi, Ashok, if the control plane is crashed, in that case, because as we said, only one machine is required for the control plane. And if it is crashed.
No. I'm telling you, if you,
Yeah.
there are two types of clusters are available. So that is tomorrow's topic. Tomorrow you will understand that.
Okay, thanks.
For time being, understand what is control plane, what is worker node, what are the components in the control plane. Tomorrow class is cluster setup, right? When I'm setting up cluster, I will tell you what will happen when the control plane crashed, how to have the high availability cluster. Tomorrow we'll talk regarding that.
Yeah, kubelet
So
will
I'm assuming
kubelet will communicate with control manager or control plane.
My God, I told 10 times, scheduler will talk to kubelet. Scheduler should identify in which worker node pod should be created.
Okay.
And sir, this architecture is for our understanding only, or when we send the request from user interface or CLI, we have to mention that
No,
this
this
goes
is for
to
our
API
understanding.
or
This
understanding
is for
only.
our
It will be all taken care by internally by the control plane. From our side, we will just send the request to the API server.
control plane, right?
Control
From our side, as a DevOps engineer, we will write the configuration and we will send the configuration to the control plane. Control plane will internally take care of all these things.
Got it. And for understanding of the internal, we are just learning, how internally it works. Okay, thank you.
Right.
Ashok, can you please share the Kubernetes PPTs as well?
Sure.
We have facility of different ports like port 1, port 2, port 3. Then what is the requirement for worker node 2? I mean, we can deploy all our application in worker node 1 itself.
If worker node 1 is crashed,
okay.
Then can you have high availability?
So we will deploy our project in worker node 1 on different ports and worker node 2 on different ports also.
Right. Okay. So the pods will be distributed to multiple worker nodes, then only you will get the high availability, right? If one worker node is down, still our application will be available on the another worker node.
Okay.
Hello.
Okay, sir.
Hello, sir.
Yeah.
I have two questions actually. So the real-time scenario, how many master node, how many worker node are supposed to create actually? 2 master node or 3 masters node and
generally, if you are going for cloud cluster, AWS EKS cluster, one control plane is sufficient.
Okay.
If you are creating your own cluster, then going with 2 to 3 master nodes are recommended. Tomorrow you will understand it.
Okay. Here actually one more thing. So the API server is only the communicate with the worker node. Is correct?
No, sir. API server will take the request, incoming request, which is coming from the kubectl, will store the request in the etcd. That's it.
Yeah, etcd is a storage
Database.
The manager is a control manager is communicating that the scheduler is schedule job to that in a worker node.
Right. That's it.
Okay.
But if we configure more worker nodes, then it will affect pricing also.
Tomorrow you will understand the setup, sir. Then you will understand the pricing.
Yeah. Hi, Ashok. This is Nagarjuna. See, whenever we are discussing about the Kubernetes, actually this is the developed in the Go language. So we are going to anywhere in the Go language.
No. This software is developed on the Go language. We no need to learn the Go language.
Okay. And one more point. Actually, here when in Kubernetes, it will be running on the auto scaling. In auto scaling, it's running on the resource optimized, or how will be running on the
based on the resource level, which is going to perform the auto scaling.
So we need to, whenever we are configure the master and worker node, we need to set up the CPU and memory high utilization.
We need to configure that information. If CPU utilization reaches to 50%, then do the auto scaling. Like
okay,
that we can configure.
Yeah, okay, no problem. Yeah. So same like in AWS auto vertical scaling, horizontal scaling, like that, correct?
There are two types of scalings available: vertical scaling and auto scaling. One is scaling the pods, another one is scaling the nodes also. That is
correct. The horizontal and vertical, like that, correct?
Right.
Yeah, thanks.
Yeah, hi Ashok. There is no limitation in creating the number of pods, right? There can be any number of pods.
Yes, we can create any number of pods in the cluster. It depends upon your node configuration, node's capacity. How much CPU, how much RAM that you have on the node. Based on that, you can create any number of pods.
Okay, this is the same case for containers also. It depends upon the capacity of the pod. The number of containers can be placed inside the pod.
Yes, you can place it, but technically it is possible. But generally, one pod will have only one container.
Okay.
Ashok.
That means one pod can have only one container.
Multiple is possible, but we will keep one container inside one pod.
Okay.
Hi, Ashok.
Yeah, hello.
Like in worker node, one is crashed, but if it is the application is accessible in worker node 2, whether all the data are present in worker node 2 also?
Yes, will be available.
So Ashok,
so
container may have.
Yeah, if worker node 1 is crashed, no problem. Our application will be available in the worker node 2. It will be accessible.
It will be accessible, that is fine. But whatever the data stored in worker node 1, whether it is also present
the
in
data
worker
sharing
node
will
2.
happen. So data nothing but you will use the database. The database will be a shared database for all these nodes. Single database will be there, right?
Okay. And one more thing, like in Docker Compose also we have scale option, and in Swarm also we have scale option. What is the difference between two things?
In this Docker, whatever the scaling, Docker Compose scale or Docker Swarm scale, they are manual scaling. Okay. Whereas in the Kubernetes, it is auto scaling. Auto scaling means if the load is increasing, it will scale up. If the load is decreasing, it will scale down.
So,
Okay,
if
Swarm and Compose, sorry, if Swarm and Compose both are manual scaling, means why we are coming to Swarm if already we have Docker Compose scale?
In the Swarm, if one container is crashed, it will recreate that. It is going to recreate that container. In the Swarm, that is not. In the Swarm, that recreation is available, whereas in the Compose, that recreation is not available.
So we can say that worker node 2 is a copy of worker node 1, sir?
You cannot say that, sir, because these are two different machines.
Okay.
You can execute same pods in the worker node 1 and worker node 2. You can execute different pods in the worker node 1 and worker node 2. Okay, we cannot say it is copy. These are two different nodes, two different machines.
Okay, sir.
Sir, in the pod or in the worker node 1, you have mentioned in container 1, container 2, container 3. So the same application can be present in other pods also, right? The same container can be replicated.
Yes.
And that controller, we don't have which pod can have which container replicated.
No. That will be taken care by Kubernetes.
Okay.
Okay, good. Thank you, guys. With this, I'm
Sorry,
stopping.
is there any scale in Docker Compose? When I run it, it says command not found.
Docker Compose. Let me check that one, sir.
Okay. The service scale is there.
Yeah, I will check that. Service scale, that is a Compose Swarm scale available in the Compose.
Right. Help be it doesn't have a scale.
Yeah, I will check that. I will look into it. I will correct that.
Okay, sir.